our research project, what we did was coordination. Coordination includes activities such as like tennis, catch, soccer, and jump rope, which are all like different parts of the body and like coordination and hand-eye coordination. So the two tests that we did was the hot potato, which is our original test, and the beanbag test, which is our gold standard test. For the hot potato test, it's a very commonly used exercise, and it also helps improve coordination overall. It's very well common among people. And also for beanbag test, it's a good coordination test because it involves your determination of like accuracy, strength, and your distance when throwing each toss. So that's why we performed both of these tests. For the first test that we performed, we did the hot potato test. This included the materials of a tennis ball, a measuring tape to measure the distance between the participant and the researcher, and a stopwatch to record the time. So what we would do is we would measure the distance between me and the participant, which is 10 feet, and we would do, for each trial, and there would be 2 trials total, we would do 30 seconds each trial. So what we would do is the participant would choose the hand of preference, and we would go back and forth by tossing the tennis ball. And when the 30 seconds is hit, then we stop and we record how many times the participant tossed it back to me in the second trial, and then we average the 2 out. As like this. If I drop the ball at any time, then we have to stop the stopwatch in order so we can get the participant's full amount of tosses. 30 seconds. And once I get the ball, we start back up. And then we would do this for each participant that we had in the trial. For the second test we performed, we did the beanbag toss. This was our gold standard test. This was good for coordination because it includes both strength, accuracy, and distance all intertwined into one. So for the beanbag toss, we had materials, 2 boards, 10 bags, beanbags, and a measuring tape to measure the distance between the 2 boards. So for the point system, the participant would do either 0 points for not getting on the board, 1 point for getting on the board, or 2 points for getting into the hole. So the setup of this test was the participant would have to stand behind the board and toss each one to the other side of the other board. Each participant would do 2 trials. Each trial would require 10 tosses each, and then we would average each one out for the participant. For our test, we did 15 females and 15 males, a total of 30, which ranged from the age of 18 to 22. So for this test, as you can see, the first 2 shots that he did were 0 points because they were off the board. For this one right here, it was only 1 point. That was because it's only on the board. But for the last one, he got into the hole, which is 2 points total. So we took all of that for the 10 tosses that they would do, and then we average it out.
So during the research study, we recorded several statistical values from our data, and we found statistical values for all 30 participants. And we also split the data and interpreted values between male and female participants. So first I'm going to talk about the data for all of the participants. So for the gold standard test, the mean for trial 1 was 4.44, and the mean for trial 2 was 5.76. Sample standard deviation for trial 1 was 1.97, and for trial 2 was 2.19. The population standard deviation for trial 1 was 1.94 and 2.15 in trial 2. Skew was found to be 0.36 in trial 1 and 0.42 in trial 2. Kurtosis was negative 0.11 in trial 1 and negative 0.15 in trial 2. And the R value was found to be 0.196. For the original test, the mean was found to be 16.2 in trial 1 and 18.3 in trial 2. Sample standard deviation was 2.89 in trial 1 and 2.50 in trial 2. Population standard deviation was found to be 2.84 in trial 1 and 2.46 in trial 2. Skew was negative 0.23 in trial 1 and negative 1.06 in trial 2. Kurtosis was negative 0.34 in trial 1 and 1.07 in trial 2. And the R value was 0.83. Now, for the statistics that we split between male and female, we found that the average for the gold standard was 3.86 for the female participants and 5.07 for the males. And we also found that the value for the t-test was 0.07, which represents a level of confidence of 93%. For the original test, the average was 14.53 in the females and 17.86 in the male participants. And the t-test was found to be 0.006, which represents the LOC of 99.94%.
So for results in trial 1 and 2 in the beanbag test, we got results that were dissimilar, meaning we calculated the correlation and got an R value of 0.19. And for the hot potato test, we calculated the R value and got 0.83. So we recorded the two charts for the first 15 scores, and we chose to scatter plot with lines to demonstrate a trend. And as shown in the chart, the hot potato test is more reliable. And so for the t-test, we got a score of 0.07, which means an LOC of 93%. And for the hot potato test, we got a score of 0.0006, which is an LOC of almost 100%. And we found that males had a higher score than females in the hot potato test because the average male score was about 18 and the average female score was about 15.
While conducting our study, there were some limitations. For the gold standard test, we did the beanbag test, and for our original test, we did the hot potato. For t-test, we had an LOC of 93% for the beanbag test, so our probability for error was 0.07. And for the hot potato test, we had a level of confidence of 99.994, so our probability of error was 0.0005. And we had a low relationship for the beanbag test. We had a R score of 0.1965, and we rounded to 0.20, just because it was closer to 0.2 than it was to 0.19. So therefore, we had a low relationship. Some limitations that caused these results were that the board we used for the beanbag test was very small. It was smaller than your average size board, and it was also very slick. So sometimes the beanbags that landed on the boards would still slide off. Also, the board was not very sturdy. When the bag would hit it, the board would slide. So to improve upon this, in the future, we would place weights, perhaps in the front and behind the board, just to prevent it from moving. These limitations all made the test much more difficult, and as a result, the scores may have been lower. We did notice that there was a high relationship for the hot potato test with an R score of 0.83. When a person dropped the tennis ball during the hand-eye coordination test, we would pause the timer. If we did not pause the timer during the test, the relationship would have been much lower. After reviewing the data, we found that the male average scores were significantly higher than the female average scores for both the beanbag toss test and the hot potato test. The difference in results could be because the males in our study were simply just more active and more athletic than the females in our class, giving them better hand-eye coordination. Also, the male participants could have simply just put more effort in the test, which in turn gave them better results. And it is also possible that the males had more experience with these specific tests. These were all limitations as a result of our tests. However, there is no research that shows that the difference in results were caused by any physiological or neurological differences between males and females. So therefore, we still cannot conclude that males have better hand-eye coordination than females.
Overall, when we learn in class for like the such as the t-test values and the r values can help us with this whole project and learning on how to get better results and more closer and more correlated results. We also learned that if trial 1 and trial 2 do not correlate, then the results, it's not reliable overall. And we also learned how we can improve in our future testing and research skills.